Today we have with us Dr. Ronaldo Laishram, the man from Manipur who is leading a major international astronomy breakthrough. His team has discovered a massive early universe structure of young galaxies, now officially named the Lok Protocluster. Scientists describe it as a city of galaxies still forming under the force of gravity. Now, this discovery gives new insight into how galaxy clusters were built in the early universe. Without further ado, let's in fact welcome him on NewsX. Dr. Laishram, thank you very much for joining us. Viewers, let's start in fact with the discussion. You led a team that discovered the Lok Protocluster, which is a vast young galaxy structure from the early universe. Tell us about your key findings to begin with.
So in the city, the life of the people, like the way of living, food, and everything is different. It's kind of different from the one who stay in the country or site or village. Similarly, when the unit, the the location where the galaxy is located, if there are lots of galaxies around, the properties of the galaxies depends on that. It is well known study at the local universe. When I say the local universe, it means that at our like around surrounding our like Milky Way galaxy or Andromeda around our universe. So, but it is a previous work. It was not unable to understand what is exactly happening at the high redshift when the universe was very young. So our finding is that for the first kind of study using the Subaru Telescope, which is at Hawaii, USA, and the James Webb Space Telescope, which is at US at space, most powerful telescope. Using these two telescopes, we are unable to understand that the environment, the overdensity, where if the galaxy is surrounded by many galaxies, then the shape of the galaxies are influenced by that environment, and compared to the one who is staying isolated. So this is one of the key finding and the very significance for with it is one of the first kind of study which we understand that the size of the galaxy is higher in the protocluster, means over density regions, compared to the field galaxy.
Right. Dr. Laishram, what were the characteristics of the four concentrations that led you to categorize them as a protocluster rather than an alignment of galaxies?
Yes, so thank you for the question. So there are different way of naming different way of saying whether galaxy is protocluster. So before going to that, maybe I will bit explain about what is protocluster and what is cluster. So protocluster is the earlier phase where no, before coming to so the cluster. So cluster is the when we say cluster, galaxy cluster, which is mostly at the local universe, at the lower at the our like when the universe is around 13.6 years old currently in current time. What we found is that that all the galaxies are located in the small regions, many galaxies, and they are clustering around. But the protocluster is the one that is the active phase of merging into a cluster. So in the layman term, what we can say is that, let's say we have the city. At the starting, we have the well-defined city where lots of people are staying. But at the early stage, roads are constructing and the buildings are starting before it's coming to the main well-defined city, right? Similarly to that, the protocluster is a when we say protocluster, it means that it's the earlier stage of the cluster. So that's why we have the four peak. So they will merge into a one very big cluster at the local universe at the lower redshift. That is why we say protocluster at the high redshift. And those four peaks, so they may merge into a very one single last structure, very very last structure, structure at the uh, younger universe. So that is why we say four peaks there. But there, for our case, we had the four peaks. But For other case, there may be 2 peaks or 3 peaks. So there is not a very well like defined that it should be only these 4 peaks or 5 peaks like that. It depends on the scenario of that place, of that location. Yeah.
All right. Now, Doctor, the galaxy that you and your team has discovered is 12.6 billion years young, if I may say so. What are the fresh insights that you've gained about the evolution of galaxies?
Yes, so I think I will explain a bit more detail. So when we say that the galaxy is just 1 minute, I will try to explain it in more detail. So the scenario is that the for elemental, what we can say is that at the high universe, at the older universe, when the universe was very young time, uh, the environment where the galaxy is located, it influences its size and the shape of the galaxy. So there is a main discovery, and so previous work in the previous it was well known. It was not understanding whether the environment where the galaxy is located influence or not at high when the universe was very young. We don't know before, and because of the James Webb Space Telescope, now we are able to understand this scenario that even at the high redshift means that when the universe was very young, still environment, the place, the locations of the if there is over density of galaxies there, then it influences the galaxy. Those galaxies located in that environment, they bigger in size compared to the galaxies which are isolated, means which are staying uh, individually. So for when if I bring it back to the scenario that in the for layman people that in the city, the people staying in the city, the lifestyle is different, right? Compared to the those staying in the countryside or village, similar like that. So even when the universe was very young, the surrounding, the over density environment influence the galaxy shape. That is the new discovery. What we found is that, and first we discovered the Lok Protocluster, which is the 4 peaks where they are clustering around now for now, and then what we found is the property is that they are kind of having the different properties than the field galaxies. And also another interesting thing is that this galaxies, what we see galaxy are not what we not they are now. They are the galaxies which we saw 12.6 billion years ago. So now our universe is 13.8 billion years old from the Big Bang at the starting of the universe till now at our current time. And but the galaxies we discover this structure we discover is like 12.6 billion years from now, and from the Big Bang from the starting it is 1.2 billion years old. Yeah.
Right, Doctor, talking about the specificities, let's talk about how Subaru and James Webb Telescopes observations helped your research in examining these distant structures.
First of all, so Subaru Telescope is one of the most powerful telescope, ground-based telescope in the world. What it means that this we have the like 13-meter telescope, so we can able to capture very large field of view. And what Subaru, Subaru we can do many science. So for my work, I work in the like the galaxy formation and the evolutions. So for us, we need a very large field of view and to understand like in the cluster, as I mentioned, the over density regions how the galaxies behave and the field galaxies how the galaxies behave. And so Subaru helps those things. So using the Subaru, we observe it, and as I mentioned, the light. Subaru telescope is we can say the telescope is kind of a time machine. Whatever we capture the light, it was some billions years old. Like for example, the sun. We feel the sun, right? So if the sun is gone now, we will not know for 8 minutes only after 8 minutes we will know that sun is gone because the light speed is constant and it takes time to reach our Earth. So that's why even the nearest sun is 8 minutes. If you think about the galaxies, it takes them lots of billions and the billions of years. That is why I said 12.6. When I say 12.6, it means that the light from that galaxy, it took 12.6 billion years to reach our Earth. So Subaru is the one powerful that we can able to get the very large sample size. Like we can get many galaxies and their properties. And but the problem is that this is very when the universe was very young and Subaru cannot get the size. We cannot resolve the galaxy image, like what is happening in that galaxy because of the resolution from the ground base. It's not good. But with the James Webb Space Telescope, because it is the space and there is no atmospheric turbulence or anything, and it's very powerful, one of the most powerful telescope, but it feels so big, it's not very large. So what the James Webb Telescope did is that it took the images or spectra or many things and with a very high resolution. So like for example, when we take the image with some very old phone, the image quality is bad. But we take with the iPhone or Samsung or very high quality camera, the image quality we can resolve into, we can zoom out and see many things. Similarly, Subaru cannot do this thing when the unit when the galaxy is very far. But James Webb Space Telescope they can do it. So that is why what I did is that I use the Subaru to get the overall statistics, like how many galaxies are there and what are the like how the light, the brightness, and with the James Webb Space Telescope, I get to one by one, and I try to get like the shape of the galaxies and the morphology, those properties. So that is how we use these two as a like companion, one for the more overall statistics and another is more resolved study. So that's how I use Subaru and the James Webb Space Telescope for this.
Right, Doctor, we are very fascinated to know about your journey. You are originally from Khangapok in Manipur's Thubal district. You completed your master's degree and PhD in astronomy at the Tohoku University before joining Naojin Tokyo. When did you decide to become an astrophysicist?
Yes, thank you for the question. So I I decided to I want to become an I was interested in astronomy when I was 6 years old. So this is a bit interesting story that I'm from Kangabok, as you mentioned. It is we have the village and we have the very large field. So when I was 6 years old, I was playing around with my friends, our locality friends, and it was dark, like around 6 p.m. or something like that. So it is starting dark, and we were running around. That one friend's, I was running, and he was following me, and so I fell down. So when I fell down, I saw a very bright object in the sky, and at that time I didn't know what is star and what are those because I was very small, and I was at that moment I didn't feel any pain, and what I found is that that object, that the bright object in the sky, it's intrigues me that it gave me the curiosity. I was wondering what is that, and I didn't feel any pain at that moment, and so and at that moment, then I keep started asking questions that why is not in the surrounding? Why is it in the up like in the sky? Then after from that day till now, I started, I keep looking at the sky, and then I grew up and I started asking many questions to my family, my brothers and the other teachers that what are those things and why is it there? And then I keep learning. I mean, starting reading the books, and I asked three questions to myself. The first question is that who am I? And it's not like I'm Ronaldo or not like that. It's not that. Who am I means who we are, like how we starting here. So this is very scientific truth that we are from stardust. The star died and we are here. And so that's the question. And another second question is that where we are now. So you may say that we are in India, but where is India? India is in Asia. Asia is in our Earth. Earth is in solar system. Solar system is in Milky Way galaxy. Milky Way is a Loken cluster, as a cluster that like that, and the Loken cluster is part of the supercluster. It's like that. We don't know where we are now. So, I mean, how the universe is starting. And the third question is that are we alone? So, is there any aliens out here? So that's the three questions which we don't know the answer yet. We know a bit, but we don't know many things. So that's how I started keep following these things, and my brothers, sisters, and everyone supporting me. And then after I did my schooling in Manipur. Then after that, in the class 12, I went to Delhi. My two brothers, like they're working in Delhi that time, and I part in the astro research campaign programs, and I discovered an preliminary asteroid with one of my team. And then also got facilitated by Dr. APJ Abdul Kalam. It was in 2015, March 31. And so that's how I kind of feeling, like curiosity and this thing. And one also another thing is that when I was in around or 8 or 9 years old, uh, no, class 6 or 7, I mean. I went to TIFR. My eldest brother did his PhD from TIFR, Mumbai. And when I went to the campus and I feel the environment, and it also inspired me for the research work things, which research means the environment which I really like. And so those like little things, it inspired me, and that's how I always fall in love with astronomy, and I want to pursue in astrophysics.
All right. Lastly, Doctor, could you give us some insight into the papers that you've authored where you talk about how dense cosmic environments influence galaxy evolution?
Yeah. So that's one. So the when I said over density, that is the over density we are talking about, that it is 4 times higher than the field galaxies. And this discovery is significant because, as I mentioned many times, that uh, we don't know much about the earlier universe, but later part of the universe where we are now, we know that environment, it affects how we grow. And like say, let's say a sign growing in a crowded city develop differently from the sign growing in a very quiet village. This is also same for the galaxy. And in the nearby universe, galaxy in the dense cluster looks very different from the isolated galaxies. They tends to be larger and they stop forming more easily. And that is we call environmental effects. And we know this for the nearby universe, but we don't know at the when the universe was very young. So why this discovery is significant? Because it pushes back the timeline of this when the environmental effects on galaxies past become apparent. So we scientists have long wondered, like when the difference between the cluster, like overdensity galaxies, and the isolated, the field galaxies, past began. And so our study shows that it was happening even when the universe is 1.2 billion years after the Big Bang, which is much earlier than the previously confirmed. Previously, we confirmed that it was 9 billions from now, like around 9 billions after the Big Bang. But our study pushes it back to the earlier universe. It means that the story of how galaxies grow is not just when they are born with, like, some people's born with a long height and a short height, but it may not. So what we're saying is that this is not because that those galaxies are like intrinsically they are born very big, but due to the locations where they are influenced, where they are grow off, and so environmental effects make them bigger. So the process began at very earlier cosmic history. So this is why the discovery is very significant. And the last question, like what will happen to the Lok Protocluster in the future? So over billions of years, those four separate concentration of galaxies will continue to grow. So they will becoming growing and merge under one gravity, like they will be merged together and eventually forming one of the very massive galaxy cluster in the present day universe. So after like some billions year later, they all merge together for a very big, massive structure. In other words, what we are observing today, like the 12.6 billion year old, is the earlier signhood of what will become in a very cosmic city when the universe reaches its current age. I think I hope this understand, or should I explain?
Absolutely. Dr. Laishram, thank you very much for joining us. It was an absolute pleasure to have you on NewsX and to speak with you.